Good morning, class. This is Miss Fulmer, and I wanted to share a simulation with you that is going to show you what happens at different time periods with the greenhouse effect. Okay, so you have in Google Classroom, you have a slideshow, and the very first slide in the slideshow is a table, and the table says greenhouse gases in the atmosphere. And so what we're going to do is we're going to fill out this table, and I'm going to run this simulation and pause it so that you can count different things. Okay, so the first place that we're going to start is the very first row here. It says no greenhouse gases. And on this PhET simulation, this is the same thing as the Ice Age. So I'm going to hit play here. We're going to let this run for a minute or so until things start to happen. So basically the Ice Age, I mean, if you think back long time ago, when the Earth was basically covered in ice, before, well, I guess after the dinosaurs, the yellow little lights coming down, that is sunlight that's coming down. So that is the sun heating up the Earth. When it hits the bottom, when it hits the ground, you can see it'll start to float back up a little bit, but it turns red. So let's just watch this and see what's happening. And we're going to notice a couple of different things here. Most of what you're seeing are the yellow sunlight photons, right? So most of the energy or most of the heat on the Earth is coming from the sun. Now over here on the left, we have a thermometer, and we can see this is showing us the average global temperature. Right now, the average global temperature, it's gone up. It's about 21 degrees, 22 now. 24. We're going to keep watching this until it stabilizes, until it stops climbing on us, okay? We're about 24. So right now it seems to be pretty even with the red and the yellow photons. So it looks like we're probably going to have around 24, 25 degrees. So we're up to 26. Ooh, we're still climbing, so I'm going to let that go. We're up to 30 now. Looks like we're at the freezing point. We're at 32 degrees, going back and forth between 31 and 32. Oh, we're still going up, though. Look at that. We're up to 35. So we will let it go until it stabilizes, until it stops climbing. Looks like it's pretty well stopped, though, doesn't it? Going between 30 to 35. All right, so I'm going to pause it right here. That's the highest that it has gotten. So now what we're going to do is we're going to go and we're going to look at the chart that is posted in in the Google Classroom for you. In the very first row there, it says no greenhouse gases. And the first column says heat energy, or the number of red arrows. I know it says arrows. They changed the simulation on me, but you're just going to count the red photons, the red lights, okay? So I'm going to give you a minute to go ahead and count those red lights. And we're going to put that in that first empty box under no greenhouse gases. Remember, no greenhouse gases means it's like the Ice Age. So let's count those up real quick. All right, I actually got about 17 of those. So you'll put that in the first box. Now the second column there says global average surface temperature. And we can see that over here on the thermometer. It tells us the global average surface temperature is 35 degrees Fahrenheit. Now, the next thing that you're going to need to complete on this part of this table is says CO2 parts per million, and that is going to be located over on the right-hand side of the simulation in the gray area. So if we go down here, we have the legend at the top, and then atmosphere during, and then about the middle of the way down, we have greenhouse gas composition, and we have CO2 here. The CO2 concentration for this time period is 180 parts per million, right? So you're going to write that in the third box there. Now we're going to see what happens if we go to the year 1750. And why do we choose the year 1750 is because that's right when we started doing the Industrial Revolution. So we started building factories and things. So now we're going to let this go. I'm going to let it run for a minute until that temperature stabilizes. And the average temperature is starting to climb up a little bit, isn't it? It has gone up a little. We'll let this go for a minute. Temperature's still climbing. We're at about 55, 56 degrees, 54. We're kind of going back and forth. All right, doesn't look like it's going to be climbing that much more, does it? All right, we'll go ahead and pause it right there. So now we're going to move down to the second row in that table where it says levels in 1750. So the heat energy, or the number of red arrows, remember the arrows are just the lights this time. So I'm going to give you a minute to count those. There's a lot of them, isn't there? Go ahead and count, see how many that you come up with. I came up with about 45-ish. So anyway, a few more, right? 45, 48, something like that. So the global average surface temperature there, if we're looking over here at this thermometer over on the left, is 54 degrees Fahrenheit. So we're going to put that in the next box. And then the CO2 parts per million, look at that over in the gray area there. That's gone up to 280 parts per million. It was in the hundreds during the Ice Age. So now we're going to take a look at it today, and we're going to see what's happening. So we're going to let this run for a minute. Remember, our average temperature was at about 54, 55 degrees. So now we're going to let it go. So today, we have factories, we have lots of houses, we have lots of stuff. We're burning fossil fuels now that we weren't burning in 1750. And if you're looking at the simulation, you can see a satellite up there in the sky. See what happens to it here. We're up to 58 degrees. While this is running, take a look at the CO2 parts per million. It's up to 388 parts per million. That is a whole lot more than it was before, isn't it? I saw it touch 59 there. 60. There's a lot more of those little photons floating around on that picture now, isn't there? Well, looks like that's about as high as we're going to get. So I'm going to pause it here. We're at 60 degrees Fahrenheit. So let's look at the heat energy, which is the number of the red dots there. I'll give you a minute to go ahead and count those. I don't know, I got like 50 something, 55-ish, anyway, more than the time before. Now the average, global average surface temperature was 60 degrees now, so that's gone up a little bit. And then the greenhouse gas, the CO2 in parts per million, was 388. So that's a lot more, isn't it? Now there's one more level or one more row in this table, and it just says lots of greenhouse gases. So let's just see if we take the slide bar here, and I'm going to move it up to lots. And I'm going to hit play, and we're going to see what happens. Let that go for a bit. See what happens to the photons. Remember, the yellow photons are the ones that are coming from the sun. So that is the heat energy coming from the sun. The red ones are the ones that are that's the heat energy that's being trapped, that's come from the sun, or that's come from the earth itself when we started burning fossil fuels and things. All right, so we've been going for a little bit. So far, we're already up to 64 degrees. Wow. Moving right along, aren't we? We can also we can play with this a little bit. We can put more oh, we're at 66, 67. We can put some clouds in there too. Let's see what happens if we put clouds in. What do you think's going to happen when we put clouds in? What do clouds do? What are clouds made of? Clouds are made out of water vapor. And water vapor is a greenhouse gas, isn't it? So if we add some clouds, if we have more clouds in the sky, that's going to hold in even more heat, isn't it? And it's very rarely a perfectly clear day outside, that's for sure. So we're at 69 degrees, 70. I think that's probably about where we're going to stop. So I'm going to pause it there. Now we're going to count the number of photons. I don't know. That just seems to be a lot for me to count, and they're just kind of scattered all over the place. At any rate, we see that the average surface temperature here, the global average surface temperature, is 70 degrees. CO2 parts per million, we don't have that because this is just a straight up simulation. And then the heat energy, or the number of red dots, is more even than it was in today's levels.